Welcome to the lesson, Areas of Shapes Made of Rectangles. This is part 2. In part 1, we calculated areas of shapes by dividing them into rectangles. In this lesson, we'll use another method. Let's take a look at the first example to see what this method is. What is the area of the following shape? This question can be solved by dividing the shape into rectangles, just like we did in the previous lesson. For example, like this. One big one here, one here, and one here. But in this lesson, we want to promote a different way to think about the problem. So let's go ahead and erase this coloring and notice that we intentionally chose a shape that will encourage the students to think about this problem in a new way. Now this large rectangle really sticks out. And we see we just have 3 squares missing here and one over here. Hopefully, some of the students will see this on their own, and if not, you can draw these lines as hints. Now, this is an indirect and therefore not completely natural way to look at the problem, whereas cutting a shape is a logical and concrete operation. However, adding parts that don't exist is less so. Let the students give the whole calculation. After they count these units, they'll find 16 times 10 is 160 minus 1, 2, 3, 4. We can see this calculation on the next page. The goal of the lesson is to promote and practice this type of thinking. We introduce this topic through a story where the story itself will help emphasize this method. Meet the kitchen monster. You or one of the students can read out the story. Jane's mother baked cookies for her daughter and friends. All the cookies had a rectangular shape. The little kitchen monster, who lives in the second drawer, knew that Jane would be disappointed when she found out that all the cookies were rectangular. So she decided to bite off one of several bites from each cookie, thus changing their shape. Let's continue. I will only use rectangular bites, the kitchen monster said to herself. Now, it's important to understand that the kitchen monster will never bite an entire row or column. The optional bites are a corner bite or a non-corner bite. Here, for example, we have an area of 12. And the kitchen monster can bite a corner bite like this, where one of the squares is a corner. In this case, a rectangle of 1 by 3, 12 minus 3 is 9. Remember, the kitchen monster won't bite off this one as well because it will not bite off an entire row or column. And here, it bit off a rectangle where none of the squares is a corner. In this case, a rectangle of 1 by 2, so we have 12 minus 2 equals 10. We see how this story emphasizes the mathematical idea. We look at the shape and think about what bites were subtracted from the rectangle. Let's continue. Soon you will receive a student worksheet. In each of the tasks there, you will have to calculate the area of the bitten cookie. For that, subtract the areas of the bites from the area of the original cookie. Note, in our activity, we will ignore the thickness of the cookies. And we move on to Student Worksheet 1. This is a page we print out for the students. And here is the page. In the first task, the students will have to identify one bite and then do the appropriate calculations. And the second task, there are 2 bites, one corner bite and one non-corner bite. And third task, there are 3 bites. The more bites there are, the trickier it is to use the imagination to add them back. The fourth task has 4 bites. We can see that without this process, no student would use his or her imagination to fill this up to a whole rectangle. After the students finish working, we go back to the app to review their answers. And here is question number 1. the students will probably say that we can see a square, 5 by 5, with a square, 2 by 2, that is missing. We can see the calculation over here. The area of the large square, 5 times 5, is 25, minus 4, and we get 21. Now that the idea is clear, we will run through the other 3 questions quickly. In class, for each question, listen to an answer from a different student and have a class discussion. And question number 2, we have 2 bytes, and this is the solution. Question number 3, we have 3 bytes, so this is the solution. And question number 4, we have 4 bytes, and this is the solution. There is something to note, though, about the last question. Let's go back to it. The instructions require the students to use the subtracting method, but there could be students who will notice that cutting the shape is actually more convenient in this case. We have a square of 2 by 2, a rectangle of 2 by 7, and one more square. Here, we wanted the students to practice a certain method, but in general, of course, we would like them to have flexible thinking to understand different methods to solve a problem, and then choose amongst them the most convenient one for a given problem. At this point, we could end the lesson. We covered the topic that we set off to explain and practice, but still, we added another series of questions to make the lesson more interesting. So we continue. The cookies with the same area. The nice kitchen monster notices that some of Jane's friends were offended because they got smaller cookies than the others. Next time, I will make sure that all the cookies are of the same area, she said to herself. On the next visit, the kitchen monster decided to take 2 square-shaped bites from each cookie. One from the top right corner of the cookie, and one from the lower left corner. I will make sure that all the cookies will have the same area. Let's continue. And here is an example to see how this works. The kitchen monster takes 1 square bite from the top corner, maybe like this, and 1 square bite from the bottom left corner. Then we should subtract these 2 areas from the original area of 48. On the next page, we have a ready example. Here's the cookie after the 2 square bites. Ask the students to calculate the area that's left, and then we can show the solution, which is 31. Now we will see our next student page. Here's the second student page. It has 5 rectangular cookies. The goal of the students is to take 2 square bites. Emphasize that the bites have to be square so that the remaining area of the cookie will be 31 square units, like in the last example we saw. Let's see it again for a moment, and here it is. We had an area of 48, removed 2 squares from the top right and bottom left, and got the area of 31. And let's go back to the student page. Here the students have to do the same, with 2 square bites from each of the rectangles. Question 4 is actually impossible. There aren't any 2 squares that we can subtract to reach the area of 31. Now, when a student says this, ask him or her to try to explain why there is no solution. Now, let's go back to the app to review the students' answers. Here is the first question. This is a 6 by 6 square. The total area is 36, and we need to reduce it to 31. To move down from 36 to 31, we need to reduce 5. Everything we're saying here should, of course, come from the students in the class discussion. Now, we can reduce 5 by using 1 square of 2 by 2 in the top right corner, and 1 square of 1 by 1 on the bottom left, so we will be left with 31. And we continue to see the solution. Next, this square is 11 times 4, which is 44. To move down to 31, we need to subtract 13. As you see, the students will have to work with square numbers. And they should see that all the square numbers that they can work with are the ones that are less than 13. And these are 1, 4, and 9. And they have to be used to create the sum of 13. In this case, 9 and 4 give us the solution. The solution subtracted the 9 from here, but this doesn't make any difference in the question. And next, here we have 7 times 7, 49. The difference between 49 and 31 is 18, and we can get 18 with 2 squares of 9. Let's see the solution and continue. Here the rectangle is 6 by 7, so we have an area of 42. So we must subtract 11 to move down to 31. The square numbers less than 11 that we can work with are 1, 4, and 9. The next square number is 16, more than the 11 that we need. Now, if we subtract a square with the area of 9, the other square would have to be an area of 2, and it does not exist, so we can't use 9. The sum of 1 and 4, of course, does not work either, and this is why this question does not have a solution. So the goal of the students here is not to solve the question, but rather to explain why the kitchen monster will not be able to succeed here. We can see this explanation here, and we move on to the last question. This is a 9 by 9 square, which gives us an area of 81. We must subtract 50 to reach our area of 31. Let's write down the square numbers that are less than 50. 1, 4, 9, 16, 25, 36, and 49. The 50 we have to subtract is 2 times 25. So this seems to be a solution, but let's try to implement it. 5 by 5 from the top right, and 5 by 5 from the bottom left. And we see there's a problem. The bytes we need are too big for this 9 by 9 square. Some students may jump to the conclusion that this question is not possible either, but it is. We can use the squares 49 and 1. And we see the solution over here, 7 squared and 1 squared, also add up to 50. And on the next page, we see why subtracting 25 twice can't work in this cookie. And we conclude. What did we learn? We learned that sometimes it's easier to calculate an area of a shape by first actually making it larger. This is not a way of thinking that is necessarily intuitive since it's not direct, and it requires the solver to use his or her imagination to add an area to the visible shape. And that's it. We hope you enjoyed this lesson in class. Thanks for watching.